Under 6.7, we are told that we can use vectors to solve problems about forces. And there is something we need to understand before we start calculating anything. And we are told if a particle is resting in equilibrium, then the resultant of all the forces acting on it is zero. And this means the sum of the vectors of the forces is the zero vector. We have had something like this when we are talking about static, a certain topic in the same unit of mechanics, so it's not anything new to us. And example 17 says the forces 2I plus 3J, 2I plus 3J, and 4I minus J, 4I minus J, and minus 3I plus 2J, minus 3I plus 2J act on a particle which is in equilibrium. And again, by the way, there's a fourth force which is AI plus BJ. They all act on a particle which is in equilibrium. And then we are expected to find the values of A and B. One thing we must remember is that when all these forces are acting on a particle and the particle is in equilibrium, the resultant force will be equals to zero. What does this mean? Now, if we add all the i's, for example, if we are expected to add all the i's, we have to add all the i's, and you're going to have 2 plus 4 minus 3 plus a, all these i's, and you're going to say all this should give us 0. And adding all the j's, these are all the i's, adding all the j's like 3 minus 1 plus 2 plus b, all these talk about j, they will also be equals to 0 because the resultant force is 0. What does this mean? 2 plus 4, that is 6 minus 3 is 3 plus a is equals to 0. So obviously a is equals to minus 3. At the same time, if we now get hold of j, then 3 minus 1 is 2, 2 plus 2 is 0, and of course 3 minus 1 plus 2 plus b, because we are told that 3j, 2j minus j should give us 0. That is 3 minus 1, that is 2. 2 plus 2, that is 4. 4 plus b should give us 0. Obviously now b is going to be negative 4. So the force that is elaborated in terms of ai plus bj is going to be minus 3i minus 4j. And those are the values of a and b. So basically the value of a is negative 3 and the value of b is negative 4. Okay.